When the problem of thermal runaway was first being investigated, the industry mainly focused on the heat transfer aspect. We now know, of course, that it's much more complex, and the between-cell challenge is also the compression requirements. Developers need to understand how the cells expand and contract over time through the lifetime of the battery. I'm Jeff Huang, Battery Technology Specialist at 3M's Automotive and Aerospace Solutions Division. At 3M, we've been at the ground floor of the EV battery science, and we continue to bring new innovations and as we gather more knowledge and understanding and as battery packs evolve. The main challenge in compression requirements for between-cell materials is as these batteries are cycled and the vehicle is used over time, these cells expand and contract with additional irreversible swelling over time. So developers need to understand this and develop materials that can withstand not only this change in cycling of the compression, but also the irreversible swelling over time. As designs transition to cell-to-pack, this issue becomes much more complex. In addition to the limited amount of space you have between cells, these cells and the materials now need to handle structural loads as energy dissipates through the system. This is where 3M's testing capabilities are key. Here at 3M, we have a variety of test methods and test protocols. They range from small-scale material-level screening tests to full-scale module testing in battery thermal runaway. On the material side, the hot-cold side test, or the HCS test, simulates what would happen if a between-cell material gets exposed to a thermal shock like a thermal runaway. Here, we have a hot side heated up to a specific temperature and compress a sample to a designated pressure while we monitor the temperature on the cold side. The dielectric breakdown strength test, or the DBS test, measures how well a material can withstand an exposure to voltage. Here, we position the sample between two probes and expose it to a voltage ramp while monitoring the current passage to the sample. This becomes important as between-cell materials need to be able to isolate that current and minimize as much of it from being translated to a neighboring cell. Tests like these allow us to rapidly down-select materials and determine the most favorable options. In addition, it allows us to understand the technical and economic trade-offs. No one solution can satisfy all these between-cell challenges. That is why 3M is unique. Here we take a look at the problem holistically and help OEMs understand all of their needs. By leveraging 3M's long-standing history in nonwovens and foam technologies, in addition to our manufacturing technologies, we're able to tune our materials to our customers' needs and specifications. 3M not only has decades of experience in the automotive industry, we also have extensive knowledge in the battery chemistry space. Our experts can collaborate with you to help identify solutions to your needs.